Welcome students. Now in this video we are going to talk about the solid state welding processes. Okay. So what is solid state welding actually? So here in solid state welding the joining is achieved by the heat or by the pressure or by using both. Here the joining is achieved by heat or pressure or both. Okay, and the very important thing is that there is no liquid phase present. No liquid phase present in this welding processes, and of course there is no use of the filler material and fluxes. Okay, and that makes the processes which are fall under the category of solid state welding are the autogenous welding processes. Okay, so which are the examples of solid state welding process? The examples we are having: the forge welding is there, friction welding is there, then the next development of friction welding, that is friction stir welding is there. Then we are having the diffusion bonding or welding, and we are also having the ultrasonic welding. So these are the examples of solid state joining or welding processes. Let us see these processes one by one. We will start with the forge welding. So first solid state welding process that we are going to see, the forge welding. See, this forge welding is one of the oldest joining processes that is known to the mankind. Okay, so here the ends of the parts, if these are the ends, see here, so this is part and this is the part. If the ends of the parts to be get joined are heated just below the solidus temperature. The end of the parts are heated just below the solidus temperature, and then we are applying the force or pressure, so that fusion joint takes place. Okay, so this is the basic thing. क्या करते हैं? The parts to be joints are getting heated just below the solidus temperature, and then apply the pressure or force so that the fusion joint is going to take place. See, this is the familiar method which is used by the village blacksmith, isn't it? And here the force is, or the pressure is applied by manually. The pressure or force is applied by manually or by using machines, or by using rotating rollers. Okay, now see here, when this material is heated, so definitely the layer of iron oxide or the coating on this metal takes place or formed. कौन सा कोटिंग, आयरन ऑक्साइड का, एंड विच इज ऑफ कोर्स इंटरप्टिंग द फ्यूजन ऑफ द मटेरियल. सो ऑफ कोर्स वी हैव टू एलिमिनेट दिस लेयर ऑफ आयरन ऑक्साइड. Yes, when this red hot material is exposed to the atmospheric oxygen, this layer is going to form onto this metal, and it is creating some obstacles for the fusion of the joint. So that is why it should be eliminated, and for that reason we are using the fluxes in this process. Okay, कौन से फ्लक्स यूज करते हैं? जनरली वी आर यूजिंग बोरैक्स and silica sand. Okay, we are using the borax or silica sand as the flux materials to flow out the fluxes, or this flux iron oxide get converted into liquid and it is get flushed out from this material. Okay, now see, this method is basically is labor intensive. This process is basically the labor intensive process, and it requires the quality of this welding is basically depends upon the skill of the welder, and of course this is a very slow process. So that's why the cost of this welding is high, or costing is definitely high for the forged welding. In underdeveloped countries still they are using this forged welding methodology. Okay, so what are the basic limitations, rather we can say? So this is depend upon the skill of welder, this is the labor intensive process, this is slow process, and this is costly. Okay, so rarely used in the industries nowadays, this forged welding technique. Okay, so this is the forged welding process. Now the next solid state welding process we are going to see the friction welding. So again, friction welding, the heat required for producing the joint is obtained by the friction at the ends of the workpiece. Okay, because of friction only the heat is going to produce at the interface of two joining parts, joining materials. Okay, so here there are the parts to be get welded by this technique, and out of that, say one part is rotating with very high RPM. The RPM is around 3000 revolution per minute, and the other is kept axially aligned. This is kept axially aligned and it is pressed against the rotating part. Okay, so here in friction welding what is there? So the parts are these two parts that we are going to join by this friction welding. Out of that, one part is rotating with high revolutions, around 3000 revolutions per minute, and the other is pressed against it, which is kept axially aligned to the rotating part. Okay, now see, when the revolution of this rotating part or the rotating part is stopped abruptly, and then we are started increasing the pressure on this fixed part. Okay, and because of the increasing the pressure, the heat is going to produce and the joint is going to happen there, and this process known as the friction welding process. The friction welding process. Understood? So very simple. So see, this friction welding techniques we can able to do it on this center lathe. Okay, when the jobs are less in size or jobs are smaller jobs are there, we can also do this operation on the center lathe machine. But when the jobs are too large, so definitely we have to go for special friction welding machines, and their ratings, if you look at the power ratings of that friction welding machines, it is ranging from 25 kVA to 175 kVA, which is far away from the general purpose center lathe machines. So that is why whenever the job size, part size are larger, we have to go for the specific friction welding machine. Otherwise, jobs are small, center lathe machine also we can able to do this technique. Okay, so one part can be put in the live center in the chuck, and another can be pressed against it, isn't it? And this rotation causes the frictional energy, which will produce the heat to make the joint. Okay, so another very important aspect of this welding is that in solid state welding, when the two parts we are taking and connecting by end to end, so the surfaces where the friction is going to happen or heat is going to produce, or they are going to get joined, so you do not to clean that surfaces. Okay, otherwise if you look at the other conventional welding processes, so we are cleaning the workpiece or parent materials by the alcoholic cleaning is there, we are cleaning it by the brushes, wire brushes. Okay, so a lot of things we are doing so that we are get the clean and strong weld. But here no need of having all this activity, because see, whenever, because of the friction is there, whenever there is a friction between the two interfaces, so the whatever the oxide layers or whatever the impurities are getting deformed, okay, and they getting squeezed out. Okay, so the cleaning will be done by the plastic deformation. So layer of this oxide can be get out by the simple plastic deformation, and only clean surfaces are now there for causing the friction, isn't it? So no any cleaning process you are required for these parts. Okay, so simply you can have the cleaning by plastic deformation. The very best example of the friction welding, you see the drill bit, which is connect or joined to the shank portion of the drill by using this friction welding. So various tools can be connect or joined by using to the shank by using this friction welding technique. So very simple, and these are the special techniques, of course, which are in the use. Now the next welding technique we are going to see under the solid state welding is the friction stir welding. So here we are having the non-consumable tool, that is the shouldered tool is here, which is used, which is having the diameter of say up to 5 to 6 millimeter, and the height is from up to 5 millimeter. At the end of the tool we are having the probe, which will forces the heat and also the stirring of the material. Now see here, in the friction stir welding, we are using the third body for having the rubbing action for the two joining surfaces. Okay, so in friction stir welding, what is there? The third body is doing the rubbing action onto the surface of the plates or the surface of the parts to be joined. Okay, so here see, this is the tool which is rotating, this is the direction of weld. So as the we are go on increasing the pressure by this tool, so what is going to happen? So frictional heating is goes on increasing, and which will lead to the increase in temperature. Okay, so this is the friction stir welding, and see, this friction stir welding is basically intended for the alloys used in the aerospace industries, alloys for aerospace industries. So this technique, it can be used for the plate thickness of say from 1 millimeter to up to 30 millimeter. 1 millimeter to 30 millimeter thickness plates we can able to join by using this friction stir welding technique. So what is this probe is doing? I already told you what the probe is forcing the heating, or also it is stirring the material during this process. See, whatever the distortion, और सबसे पहले तो very low heat input for the process, very low heat input for the process. Then there is a low distortion and low heat affected zone in this stir welding, friction stir welding. And of course there is no any spatter. So these are some advantages of the friction stir welding. Basically it was intended for the alloys which are used in the aerospace industries. Okay, so this is just we are having the extension of friction welding. Friction welding was used for the symmetrical parts which is having the rotational symmetry, but here we can able to join the plates, okay, by using the third body which will cause the rubbing action, which will produce the frictional effect or frictional heating, and it will raise the temperature of joining surfaces, and joint can or welding can happen. Okay, so this is about friction stir welding. Next welding process in the solid state welding, we are having diffusion bonding or welding. Diffusion welding, or rather we can also call it as the diffusion bonding. So see here, in this diffusion welding, the strength of the joint or weld is obtained is primarily because of the diffusion. That is, diffusion is nothing but what? The atomic movement at the interface of the two joining surfaces, and secondarily by the plastic deformation at the contact surfaces. These are the two basic things which gives the strength to the diffusion bonded material or diffusion welding plates. Okay, so first thing, the strength is obtained because of what? Because of the atomic movement at the interface of the joining parts, that is nothing but the diffusion. And second is the plastic deformation at the contact surfaces of these two joining parts. Now see here how this intimate contact is very important for having this diffusion bonding, which is obtained by the application of the pressure or the forces. And one more important thing about this diffusion welding is that, as we know that the diffusion is time dependent phenomena, so for very good diffusion we should have the temperature, that is, it is a rate. Okay, so rate will be goes on increased by heat, or temperature goes on increasing, then the diffusion rate goes on increasing. So of course this, to get this diffusion, proper diffusion, we can have the temperature here. So how much temperature we can go in the diffusion welding? So see, in case of the low melting point materials, the heat or the temperature in this process can be the half of the melting point of the material. Okay, कितना टेम्परेचर तक जा सकते हैं हम डिफ्यूजन वेल्डिंग में? That is, we can heat the material up to the half of melting point of material, melting point temperature of the material. For what? For low melting point temperature materials. Okay, intimate contact, obtained by application of force or pressure. Okay, and the strength of the joint or weld depends upon first diffusion, primarily it is based on diffusion, and second by the plastic deformation. And we know that the diffusion is temperature dependent phenomena. We can go on heating the material just half of the melting point temperature of the material for the low melting point temperature materials. And this diffusion welding is basically used for joining metal to metal and also for joining metals to non-metals. So this is about the diffusion bonding. Okay, nowhere in this processes till now we have used any kind of filler rod, any kind of fluxes, isn't it? So these are the autogenous processes, please remember. Now this is the last solid state joining process we are going to see, that is the ultrasonic welding process. So see here, this ultrasonic welding process is basically used for the joining of the foils or strips. Okay, so this is the schematics of the ultrasonic welding. So this is the ultrasonic head. Okay, this is the concentrator or horn. This is the horn or concentrator. Okay, this is our coupling bar, which is going to apply the transverse pressure between the workpiece, and it is also going to vibrate with ultrasonic vibration. This is the anvil and these are the work pieces. Okay, so see here the magnetostriction. Here the core of magnetostriction ultrasonic generator Here the core of magnetostriction ultrasonic generator is coupled with the work by using this coupling rod having the suitably shaped tip is there. Okay, and when this tip is applying this transfer pressure between the work, applying the transfer pressure, say this is transfer pressure between the work, and at the same time it is having the ultrasonic vibration, then there is the spot is getting generated at the interface of the workpiece. Now this is the weld spot we are getting between these two workpieces. So this is how the weld is formed, the spot weld is formed in the ultrasonic welding. So if you see how actually this weld is going to form, so here see, when this transfer pressure is applied by this coupling bar or tip of this bar and also with the vibration, what happened? So at the interface of these two workpieces, so there will be the fracture or failure of the brittle oxide layer. Okay, and at the same time, whatever the asperities at this interface are getting softened. Okay, so once the layer of these oxides are brittle oxide layer is going to fail, and the second is what? The asperities are becoming soft because of the localized heating. Okay, so this is how the weld is going to form in the ultrasonic welding. Please remember, in ultrasonic welding we are able to use this welding for joining of the foils and strips. Okay, so this is about the ultrasonic welding, and here we have seen the solid state joining processes. First we see in the forge welding, second is the friction welding, third is the friction stir welding, fourth is the diffusion welding, and fifth we have seen this ultrasonic welding. And please remember that these all are autogenous welding techniques where no fluxes, no filler material or filler rod is used in the operation, as there is no liquid phase is present. Okay, thank you.